So, Drizzle, in the beginning. So, I was Director of Architecture and Director of Technology and even engineering at MySQL for a number of years. Rolled around about 2005, and we were releasing 5.0. Now, 5.0 was a fairly big release. We had went and had a number of customers who had said, hey, for us to bundle your database, we need sort of views, triggers, and so forth. Come 2005, I started talking to, went back around and started talking to customers. And at, particularly that year at the MySQL Users Conference, we had a customer advisory board, and we sat and said, well, hey, this is 5.0, and this is what we've been doing. And in the room, I kind of made an observation. The observation was, as soon as I said views, stored procedures, and triggers, a number of people in the room were like, eh. And they were like, not so happy. And I started asking, okay, so which of you are interested in these features? And any of the OEMs, so basically the companies that specifically wanted to, say, ship MySQL as a bundled product, they were all excited about this stuff. But the Yahoos and the Facebooks and the Googles and the others of the world, they weren't really so hot on this. They were like, hey, when you worked on replication and you worked at X, Y, and Z, they had a number of features that really were a lot more important to them than any of these other features. And to some of them, these features were complete drawbacks. Google, went into the source code immediately went 5.0 and just commented out stored procedures, views, triggers. And then the same thing has occurred in a number of companies. They're like, you know what? These are anti-features. They're not our design practices. We don't even want them in there because we don't want people using them. This is not where we want our business logic. We have a very different model. What are you guys going to do? What are you going to do for us? So what I did is I started taking notes. And I started going around and talking to different people and saying, hey, what would you really like to actually see in the database? What are you interested in? What would really make things go for you? And from that, I kind of started collecting notes. Okay, 5.0, not very interested in. What are you interested in? You're more interested in some of the replication. You're interested in how we're actually going to scale this stuff, maybe to multiple cores and so forth. So about around in 2008, Sun bought MySQL. And at the time, I was like, okay, that's interesting. You got MySQL, you're going to compete against Oracle, that's great. By the way, here's a bunch of other customers. These are the customers you're interested in. But they're not really that at all interested at all in what you're doing right now, what we've been doing here. What we think about is actually taking the database, going back down, looking to see if we can put some maintainability in it. Unireg had been started, which was the precursor to MySQL, close to a decade or so before. So at this point, we're running on a code base that has not been, actually had much updates that occurred for a very, very long time. Just been kind of added on, meld something else to it, add on. So the maintenance nightmare is pretty high. So what they said is, okay, take a group of engineers and go off and see what you can do. So what we did is went, took the MySQL source base, started making modifications on it, and then put it up on the web for people to use. Which is interesting. What was also interesting at the time is they said, well, I was really interested in saying, well, it's great, but MySQL has a lot of licensing problems because of the connectors, and there's some history there, and there's all kinds of issues. And they're like, well, you know what? We're familiar with the VSD license. And I said, okay, great. I'd like to take our connectors, have a brand new set of connectors done. Won't, touch the MySQL ones, but we'll actually put connectors on Drizzle to allow people connect to Drizzle from any data, from any application. We don't really care. Sun's business was not the OEM business. They didn't care. So what we did is we were actually also at the same time able to make a couple of other changes. We were able to make changes like, for instance, put our drivers under BSD. We were able to look at ways of actually bringing in developers that we couldn't before. The copyright really isn't that much different. It's not that interesting. If what you're really interested in is in getting a group of developers to start actually committing and working code. Anything that requires a developer to get a piece of legal paperwork signed is it's pretty much a roadblock. They hit that, they don't want to get it done, everything stops. So what we did, we decided, hey, let's go take, when we put the code up, and let's start just tracking who did what. Let's make sure that we can track it back for copyright violation, but let's ourselves not be that concerned about the copyright. So Drizzle was born out of all of this. And then about 2009, Oracle buys Sun. And then right about 2009, all the Drizzle developers, either weeks before or on the day of the acquisition, decided to find somewhere else to run the program. So coming around 2010, Drizzle developers split from Oracle and the acquisition was finally completed. And then this year, we were able to finally complete the GA about a year after that date, thanks to Rackspace and a number of other companies who have been supporting us. So Drizzle number 7. This is where we're actually at right now. Quick update. So this is Drizzle. Drizzle, MySQL's architecture was monolithic kernel. Everything was built into one thing. There really were no interfaces. There wasn't any way to put new pieces here or there. It's a very monolithic design. It's very interdependent on every piece on it. It's also very difficult to make modifications to, because when you change one thing, you have absolutely no idea what might break on you somewhere else. So we went back and started reworking Drizzle. One of the things we did is we went with a microkernel architecture. So inside of our system, we have a number of sets of APIs and different services that are all running inside of the kernel, and all of these make up what is Drizzle. A lot of times people ask, well, so really, you mean Drizzle is, you're using NODB, right? You use an updated version of NODB. Okay, so the difference is Drizzle's internals is the microkernel architecture. This is what allows us to write a lot of plugins and extend a lot of different things. So basically, we have a thing called, we have a listener, we have a parser, optimizer, executor, but we also have other things that are actually in the system. We actually have logging, error reporting. We can connect out to these different systems like Memcached and Gearman. Our listener ability can actually listen in on things like HTTP ports. We have blog streaming, where we can actually hand somebody back an ID and then stream them back a blog directly, so you don't actually have to go through the SQL interface. We have an experimental interface where you can actually hand stuff to us in JSON, and we'll actually reply back to it. There's a number of little things that we've done. It's been really kind of a funny world to be able to kind of take this, what is monolithic design. And same thing like when we started doing storage engines. When I first kind of worked on, one of my big dreams coming to MySQL initially was I wanted a storage engine interface so we could actually start connecting in multiple systems. Drizzle is the result of creating many different interfaces in it, so we can plug many different things in. So one of the other big things we wanted to look at the time was no gotchas. There are a lot of things in MySQL that if you're not watching what you're doing, you pretty much shoot yourself in the foot. One of the things, no null when you don't want null. It kind of drives people crazy. They'll go and they'll add some kind of field, do some kind of alter table, they'll put not null, and then when they go back and they show the create table, it's got null in it. Okay, so what's happened to that? Well, that means that in some cases, well, you can't just alter a table, add a field, and not put a default value, or say not null. Because what's the result of that? The new column that you add. So MySQL, says, well, even though you said not null, we're going to add null for you anyway. And there's a lot of little things that it does there. And a lot of it's about pretty much, at the time, trying to handle situations that could not really be resolved. It was interesting. I was listening to the Mongo guy at this point. He was talking about, well, we're atomic on a document. But if you make changes to multiple documents and you get halfway through that, what happens? Well, if you had 10 documents and you get halfway through, that means half your documents are updated and half your documents are not updated. We always had that same problem inside of MySQL. If you run an update, if an update ever would upchuck on you on a row, what happened? Half your data was changed and the other data wasn't changed. And so you'd be sitting there with no ability to say, well, what do I do now? I can't go really revert any of that stuff. So in Drizzle, one of the things we did was we wanted to take out that kind of stuff. So Drizzle, internally, from the get-go, is a transactional database. The entire thing from bottom on up is transactional. That means we can do rollbacks, we can fix updates on rows, we can do all that stuff. Anything that really kind of resembled the ability to do a non-transactional database, we stripped all that stuff out. It fixed an awful lot of bugs, but it fixed all kind of gotchas at the same time, just by saying, okay, it's going to be transactional from day one. There's also a lot of other little things we looked at. We looked at things like date time. When we first started Drizzle, this was a couple of years ago, there was some things that were kind of obvious on the wall, and that we knew we ought to shoot for. For one thing we knew, nobody was going to be running 32-bit machines by the time we actually hit GA. That entirely didn't matter. We didn't even think entirely 32-bit machines mattered. Can we compile and run? Sure, we can compile and run. But let's really think about ourselves as how we need to optimize and what the hardware we need to optimize for it was going to be now. So what is it? Drizzle's date time entirely, 64-bit internally.
We have microseconds. The whole database is built on IP version 6. It's been weird. This has actually been a strong deployment reason for Drizzle, it's turned out, because people will need an IP version 6 database. And I think we're the only open source IP version 6 database. We're also the only open source database that actually has this bug tracking system too, which is also kind of a fun thing to also find out. So anyway, a lot of these stuff is we thought to go for. So we looked at things like, we immediately started looking at, hey, what do 16 cores look like? What does it look like if we have a lot of RAM? Things like the key cache. The key cache doesn't matter at all. It's got one big giant lock around it. And you can't even disable it. So anybody who's got, you're thinking you're doing yourself a favor with the key cache, well, truth is you can't do yourself an unfavor with the key cache. It's sitting there, it's got one lock, everything going in and out of it. It's a big giant bottleneck. Turns out, by the way, nowadays, disk, fast, caching, everything else that's going on, key cache makes no difference whatsoever. And things like, for instance, the query cache never mattered except for on some benchmarks in one place. The query cache sits in the middle, has one big giant lock on it. Just doesn't work. So we removed a lot of that stuff so we could actually get a lot more performance out of the system. One of the other big things that we looked at the time, we said, well, the character set system is really kind of complicated. You would ask somebody like, what exactly was happening inside the tables, and they go, well, yeah, we designed our site for all this international, and we've been, happily accepting stuff from China and India and everything else. And then you go in and you look at their tables and it says show create table, and I'm like, your default character set is Swedish. Because the default character set in MySQL is Swedish. Most people don't know to actually set that. They just assume that the incoming data is actually going to work, let alone worrying about things like collation. They'll be thinking, well, we did a binary collation, that'll work, right? No, doing binary collation won't actually work. Lots of Chinese characters are entirely out of order. It turns out you just can't sort them by integer. There's a lot of these things that just don't actually function. And the data that was coming into these sites, it was all UTF-8. That's what the web is. The web is UTF-8. People's applications do it. When we first launched this, we had some people who said, oh, well, we have to worry about Asia. And at the time, one of our developers who was in Asia did a look inside their databases, inside of Mixi, and he made an observation. There was so much English that they had embedded in their language because of names, and, pop stars, you name it, and spaces, that the difference between UTF-8 and UTF-16 in actual practice and the reporting data was nothing. So the whole UTF-16 complication, we can keep everything in UTF-8. It just turned out fine. So we store everything in, and we take everything out as UTF-8.
Would you like functionality
at the end. So Drizzle from day one and from end to end is UTF-8. The client is UTF-8. The server is UTF-8. You don't have to actually go in and set any character sets. You don't have to worry about any kind of connect problems where somebody didn't set a client correctly and they talk to the database and the whole data corruption thing occurs. We don't have to worry about that. Another big thing that we wanted to look at was replication. The original replication for MySQL was written in about 3 months. Sasha did a great job, and unfortunately, people had to fix it for probably 12 years. Pretty unfortunate. So basically, layer on layer on layer and fixing it. So logical-based replication was kind of easy to implement at the time. There was an attempt inside the 5.1 trees to create row-based replication, and to create hybrid replications, and it pretty much in the end made the code pretty unmanageable. If you cannot take a MySQL server and take another MySQL server between different versions, and really hope to hell that they're going to replicate together, that their messages are necessarily going to pass. It just doesn't work. You can kind of do it between very minor versions, and even that hasn't always worked all the time. Well, I'm just sitting in the audience, like nobody probably like that description somewhere. One of the guys who works on replication. But that replication, there is no protocol, there is no nothing. It's just a set of data going back and forth. It's tweaking every little version, it's tweaking every version, and you really don't have any good knowledge of what's going on. So when we started reforming replication, it was one of the pieces where we went in, spent 2 days, looked at more code, and then we just cut the whole thing out. The time it took to actually rebuild it or try to strap it together or figure out, it just wasn't working. We were able to then go back in and put hooks in the proper place, so that replication actually properly worked with transactions. And at the same time, what we were able to do is say, what do we want as a format? We need some kind of format. We got to send this stuff over the wire. At the time, Google had released protobuffers. They had a great C++ library. It was BSD. They were very friendly about making any kind of changes we would ever want with it. So what did we do? We actually went with their library. So our entire protocol for replication, from the point Drizzle actually stores stuff, the things that we send over the wire, is entirely a Google protobuffer. We take create statements, create table statements, alter table statements, and actually translate that from SQL into a protobuffer message format. And people have been able to do some pretty wild things with that. There's a demo where one group actually had data incoming to Drizzle. They went into Rabbit Compute, and then was actually then changing some online stuff that people were like, who was using what on the planet via browsers. It was pretty awesome to see this stuff. So we've had a lot of people who've been able to take Drizzle and say, well, we have this other back-end system that we actually know we do stuff with. The first replicator for Drizzle I wrote in Python in 30 minutes. That was that easy. It was simple. What did I do? Took Python plus library, pointed it at the port, pulled the data out, and actually started to go with that. That was all it took to do. Nowadays, our database actually has built-in slave threads and actually I/O threads that can sit there and pull data back and work on it. But it's all working off that same message format. Literally, when a slave database goes and connects to Drizzle, a master database, and it grabs data, it does a select. It does a select. It has a protobuffer piece of data. It transfers the protobuffer data over, and it can execute it however it wants to. The protocol is entirely open. The tables are open. And you can pull data out of it. If you've got enough privileges, you can even delete data from it. The replication is really simple now. And the thing is that we looked at this and said, well, what else could be simple? Well, one thing that was not simple was the binary logs. How many people here had to say and deal with at some point a corrupt binary log? At you? Okay. Probably don't have that many unless you're on your production. The rest of everybody's lying.
Nobody else doesn't use binary logs because they don't use replication, so I
We just hadn't noticed.
So the replication log itself is a separate file from the actual transactional log. Okay, so what does this mean? This means that every so often you get somebody at Facebook, probably Callahan, screaming about, yet again, replication is broken, it has no ability to actually be durable, and read his rants. This happens with some frequency. It's very problematic. And it's problematic, why? Because it's sitting over in this file. You've got this you've got this other log that's here. You have this two-phase commit that has to occur across this whole thing. Many things can go wrong, and it can be very, very slow. That's why most people just turn the binary log on and they say, just sync every 5 seconds. We'll just lose the data, or we'll be corrupted. It'll be fine. And they don't care about that until what happens. Well, the machine dies, and suddenly they've lost data around corruption. So one of the things we decided within Drizzle was, well, let's get away from this. Let's really not do that. So what can we do? Well, one thing that we can do is we can actually take all this data that we're seeing, insert, update, and if we're going to build a protobuffer message, let's actually keep the messages so that we can segment them, so we'll keep IDs on them. But let's actually store them in a transactional manner. Why don't we just use the MDB log that we've already got? I mean, we have to write the I/O out somewhere, whether the I/O gets written to a separate file or gets written inside of MDB. It really doesn't actually matter all that difference. The big main difference was, what happens when you call sync? If I have to actually time two files together for some form of two-phase commit, it's going to be a lot slower than if I'm just pushing everything down in this file and it's calling sync every so often and using the elevator operators that are already there for me. We actually have a log. Let's just use the log, push more data into it. Because really, when it comes down to the actual machine itself, does the machine care if it goes to this file or this file? The machine doesn't really care. You've got a channel, you can fill the channel up as much as you can. That in the end is really all that actually matters. So what we do is, we have the transaction log, but instead of actually storing this to a bin log, we just store the transaction log. So this also means that we hit commit on a transaction, or a group of transactions are actually committed together. What happens? It means the data is stored. You know that when you come back, the replication data is exactly what was actually stored on disk. So there are no indiscrepancies that actually occur. And since all of this stuff is basically vectors of changes, this isn't a logical-based replication. This is not the statement-based replication that MySQL first did. What we do is take the vectors of the changes and store them. So we know exactly what rows got changed, and we change exactly those rows on the other end. So for instance, later on I'll talk about this, when you're actually starting to build farms of data, where you're trying to do some kind of analytics, where you take multiple databases and start putting them back together. That means when our replication comes in, we change just the rows that were changed in the original database, which makes a lot of things much simpler. So the whole thing is entirely single sync. It's entirely transactional. It's safety and storage. There's a lot of stuff you can do to gather. Determinism, like I said, it doesn't matter. You don't need to worry about your SQL query anymore, whether your SQL query has some piece to it that might make a non-deterministic behavior occur that would mean that your data when replicated won't be replicated correctly anymore. I.e., you're probably using views, because they're not actually deterministic in MySQL. Nice thing about this stuff, you actually get to sleep at night, because your replication works. One other big thing I talked about when we came up with, when we first started working with Drizzle, was actually libDrizzle. libDrizzle supports Drizzle, it supports MySQL, it supports SQLite. It has asynchronous features to it. By the way, it's also BSD, which means this whole question of, well, my application is this, and so your library is this, and my server is this. The question is, what are you connecting to? What are you linking to? You're linking to some BSD code. BSD code you can link to. It's lawyer free. The goal of this is that we can actually start talking more about the technology and stop talking about ongoing discussions about what is legal linking and what is not legal linking. And that was the goal of it. Basically be lawyer free.
What does that mean, of course?
libDrizzle can speak both Drizzle, which has a slightly different protocol. It can actually talk to MySQL itself. So Drizzle itself can communicate with it on the MySQL port, it's a MySQL server, and it communicates on its own port as well. So for instance, if you already have a client application today that's connected to MySQL, push the schemas over to Drizzle, push the data over there, run. You can run a MySQL client against it. Our client can also talk to MySQL as well. So we have people who end up using our clients instead of using the MySQL clients, just so they don't have to deal with any kind of like, well, what was my whole licensing stuff? Like, what was it? Node.js? Is that the one?
Node.js?
Yeah, Node.js actually uses the Drizzle, a number of other things too. Other things about it, our clients. We are clients in Docker instances, so storage can talk to Amazon S3. We've had people who have built things like, for instance, the blob streaming engine. The blob streaming engine can actually take incoming data from the client. So the client says insert, take blob. What can the blob streamer do? The blob streamer can even throw it up on Amazon S3. So we've seen people actually do these sort of hybrid systems with Drizzle, so they don't have to keep anything in particular in one place. We're not stuck in one paradigm. We'll see a little more about this going as we go forward. Is there more to this whole thing? Yeah, there's a lot more. We worked on this thing for close to 2 years. There's a lot of features in it. And I even forget some of them sometimes until I'm feeling like, for whatever reason, no.
3
We
years.
have been, huh?
3 years.
Yeah, we have no cost off. No cost off means that, where's your authentication for your application? Well, if you're using it on Amazon or something like that, you probably have some client stuff. But on the other hand, if you're using it inside a VPN or someplace where you're controlling the network on it, I don't know how many places I've run into where the username is root and the password is null. That's really extremely common. The problem is in MySQL, at one point I counted, you have to go through 12 different blocks, even when you have root null. Even if you turn off skip or skip grant tables, you still have to go through locks. It's still costing you locks to go through this. These are all single locks that if you have multiple clients coming in, they all have to wait for each other to get through this lock. If you've got a box with a lot of cores, that can become a lot of locks. Start adding up more cores, you get a lot more lock contention. Our usual goal is to remove lock. So we have no cost off. If you don't actually want off, you don't want to load any off modules, that's fine. If you do want to load off, we have off modules for PAM, we have off modules for PAM, we have. When we initially released the API within an hour of it, somebody actually uploaded an HD method for one of the cloud vendors so that they could actually have incoming users authenticate from the database back out into the cloud. So that's how they do their authentication. We have table functions. We have a thing called the data dictionary. The information schema inside of MySQL does not follow the SQL. Does not follow SQL standard. In fact, when I started looking around, it turns out that except for really SQL Server, nobody actually follows the SQL standard. It turns out when it came to the information schema. So we wanted to go back and create an information schema that actually followed the SQL standard. And in the process of that, though, we want to generate more tables. So we have the ability to create table functions. We can take anything inside the database and represent it as a table. So there's a lot of little like new information, things like what's actually happening in the table caches, what's actually happening in these converted tables. We just can write pretty simple table functions and then display them for you. And for that, we created a thing called the data dictionary. Inside the data dictionary, you can find all kinds of gobs of information. There's close to 36 tables in there where you can find things about like what's happening to performance, what's happening to threads, all of that stuff you can find in there. You will also find in Drizzle an information schema. An information schema we have kept to be exactly the SQL standard. So if you write something and you're against the information schema, guess what? In theory, as long as you're talking to or the other database at least mostly follow the SQL standard, your applications will work against multiple databases. So things like finding out what tables exist or what fields exist and all of that, you can just get all that information out of the information schema. So it's kind of handy that way. The information schema is entirely the SQL standard. The data dictionary has all that information and has a lot more information in it that is Drizzle specific. So that's where we put everything that is specific. We try to keep the two very separated so that we don't have issues with, say, somebody coming along and saying, oh, well, guess what, you modified the information schema over here and it won't follow the SQL standard. So we keep all the SQL standard stuff here. We keep all of our additional information over there. We have other UU types. We have built-in UUIDs. UUIDs are native types inside of Drizzle. So if you want to generate a UUID, we have a native type for that. It's great for storage, great for comparison. We have a native Boolean type. Inside of Drizzle, there's an actual Boolean type now. This isn't an integer 0, 1, or something that says yes, no, or something that says true, false. It's an actual real type, which is a Boolean. When you go store stuff in the table, it's actually Boolean. If you've ever done, like, for instance, a Boolean with an enum, you say enum, true, false. Okay, the problem is, it doesn't have logical operations that can work inside the data. So if you're trying to do comparisons and any kind of SQL statements, it's not actually, so you can actually have logical types in this. Other big problems would be enums in general have a big gotcha. You have an enum that you say is true or false, and you insert the word cat, depending on the database mode, then it stores 0. So it doesn't really kind of function very well. So these are actual true types. Something that, things when I do these slides I forget to. Inside of Drizzle, we have things like assertions. We can actually tell you type info. We can ask, like, for instance, what is the result of a combination? Can you tell me what the type of the result will actually be? We have a lot of stuff that allows you to do self-describing stuff, actually in the parser itself. In our parser, conflict-wise, we're at about 82 conflicts nowadays, close to 180, close to 200 conflicts inside the MySQL parser. We spend a bunch of effort to actually streamline the parser down and do a lot of improvements in it. So our parser nowadays tends to be a bit faster, and it's certainly a whole lot less conflict resolution. The only difference is in types. We remove the set type. Anybody here ever used the MySQL set type? Yeah. Ever try to use indexes against it, or search on it, or read the manual where it says this thing is broken, please don't use it? That particular type is broken by design. We decided at the time, you know what, we're going to remove it. If we ever actually add back a set type, which we have a design for, we're going to do something that's not so quite broken. So what I'm going to now talk about is the Drizzle 7.0 stuff. I'm sorry, 7+, and this is what we've been working on lately. So replication, what have we been doing? This is what people are accustomed to, right? You got a master, you got multiple slaves. Master, your slaves read from, your master. It's great for actually scaling out any kind of read traffic that you've got. Okay, works well, been around for a long time. But typically, you don't only need to really scale out reads. In fact, a lot nowadays, we need to actually scale out what? Writes. So one of the big things that we started looking at was, well, how can we actually build a multi-master system? So that, for instance, everything can feed back and forth. So in this case, when we have slaves, that can read from the master can read from the slaves, slaves and masters. In our environment, we can actually have what we call multi-source. Any given machine can read, this is the default number, it's a compile, up to 10 other machines. So what it can do is you can take a machine and say, guess what? You have already, in my environment, I sharded 10 servers out here. So I got 10 servers I sharded out here. You can take one machine behind all that, and that one machine can read from all 10 shards. What does that mean? That means that when you go back to doing the reporting, you have a single database that can actually do reporting. So you can shard all you want to, and then feed that data back into a bigger instance, and that bigger instance can then do all your analytics at that point. So you have all the advantage of sharding on the front end. The user can sit there and pull data based on their needs, you can shard, and you have the advanced on the back end. You can run analytics against all of that data that was sharded up front. And kind of groovy thing, the fact that our replication system does all this nice transactional stuff and improve transactions on the slaves, things run much faster. Our replication is usually about 2 times faster than MySQL replication when it's underway. So we can do an awful lot more with I/O. So you can actually handle something like by creating lots of shards, bring those back, and then apply everything. So in our world, masters can talk to masters. We don't really care. We don't have to. So, yeah, next slide is shard slide. Look for myself, jelly fix. If you can imagine, flip the machines up, flip all the machines on the right over to the other side. You've got a bunch of sharded databases. You can feed it all back into one database. Another big piece that we actually started working on is the problem of, well, here's the thing. You've got a database, and in some cases you're probably running that database on Zen or VMware or whatever else. Bad news. Virtualizing a database, very bad practice. Why? Get performance of about 40% off, we find. Problem is, you have an operating system, virtualizing an operating system, virtualizing a database. The difference between a database and an operating system, people who write databases don't have to write sound drives, thank God. That is pretty much the only difference. We have scheduling that's going on, we deal with I/O, we deal with all the same things. Database and sitting outside of is basically using the operating system that we're building most times. You start virtualizing that, and the further you get on that, it just doesn't turn out right. So virtualizing databases is not really been it's a very expensive thing to do. So what we want to do is find some way to actually cut the costs on that. In 5.0, there was a thing called the instance manager, which in theory was to be to actually solve some of that, but never really got finished and didn't really get a whole lot of love. We went back and started working on this about 7 months ago. We were doing some work for Rackspace where they were like, well, you know, we'd actually like to cut a bunch of our costs. Can we do that? I said, well, what we could do is actually have a database virtualize itself internally. We already have scheduling. We already know the fact that our threads exist. We already have catalogs. We can do all of these pieces. So in Drizzle, what we've actually started doing is building catalogs. And a catalog is interesting for a few reasons. One thing, catalogs can each have a schema. They can have multiple schemas. They have their own user groups. They have their own tables sitting inside the schemas themselves. What you're seeing is unlike what a lot of the hosting solutions you go to now, where you connect to a database, and when you connect to that database, you're given what? One schema. Well, how many people install applications that are going to need multiple schemas? When you start having like juggle tables around and all that, that's because you don't have multiple schemas. So in Drizzle, what we've been working on is we actually have our catalog system so that we can hand a user, use a virtual IP to do this. So your IP version 6, great. Somebody comes and connects in on their connection. They don't need to know what everything else is running. We handle it. We come in, we drop them into a catalog. At that point, they can create schemas as much as they want to. They can create users. They're fine. They are in their own sandbox at that point. What's great about SQL in this regard? Hard to have a security problem when there is no syntax that allows you to connect. There is no syntax that allows you to select from one catalog to another. You know, this is the problem that you run that the hosting providers go off and have run into. At any point, anybody messes up security at all, guess what? That schema can then see another schema. You get to find out what your neighbors have in their own data. You can even start looking at things like, you know, what? You have to restrict out the information schema. Some of the hosting providers just disconnect that, so now you can't suddenly find out exactly how, you know, what's even in the database, because there is no separation inside these things. So in Drizzle, the data dictionary itself is actually broken up in the catalog system. You can't see what's in other catalogs. And the nice thing about tables, there is no SQL syntax. You just can't do it. You cannot select from one catalog database schema to another. It doesn't exist. There is no execution path for the security violation to occur in the first place. That's important. So this was something big that we've been working on. Cuts the 30-40% hit from virtualization. Suddenly, you can run an operating system. The database can sit on a machine, and you don't have to virtualize any of this stuff. So that whole heavy duty cost that you might have been having to pay for virtualizing all goes away at this point. It also means that you have a single instance to manage. You got one database sitting here that's now running. That database that's running, you're having to manage. Instead of, say, for instance, if you virtualized where you didn't have to do what? You're having to manage the virtualizer. You're having to manage each of the given operating systems, and then you're having to, on top of that, manage each of the databases in there. That's a lot of overhead in management instead of having what? One database that's sitting there and doing this work. Other than probably about DB2, IBM's database, not a lot of people who've actually really worked on this stuff or started pulling this stuff apart. Then thanks to their mainframes, why they work on it. So for us, we consider this kind of a fairly big deal and something going forward we put effort into. Because really, like, if you think about it environmentally, it's pretty bad to be running all this additional hardware when really this is not something that really should have been virtualized in the first place.
So that seems to help for multi-tenancy at a hosting provider. What about multi-tenancy for application providers? You know, like stuff like DBs or other things that Oracle provides to do virtualization of applications. Is there anything that helps, that this helps with or not?
Well, I mean, from the application layer, you can have multiple applications all talking to the same instance. And as long as you put each of those on their own catalog, then you're doing fine. So you don't have to worry about any kind of overlapping scheming. Also an advantage of this thing, because there is no shared locking that goes across the catalog system, because we don't need to worry about that shared locking. So, for instance, if you're doing any kind of locking that requires locking up like if you're locking all the schemas locally, or you're locking tables, these two applications are running in entirely different catalogs. There is no locking that needs to actually occur at this point, because they're all inside of their own framework. So it's kind of advantageous as far as even if you're not even virtualizing anything, just having these things running applications where you know there is no overlap.
It would have been the same thing for each time and it needs to separate the virtual regions from its own multi-tenancy. Does that help? Or
The answer is maybe I have to see the application. So it sounds like it would be. I really have to know the use case. Anyway, all of this still allows, IO to be spread across SAN and NAS and all the other great stuff. So that's all pretty good. One other big thing that came in 7.1, Percona actually has been supporting and pushing fixes for us for their hot backup. It supports partial backup. It's no locking. Single solution, point-in-time recovery and single solution. Oh, and by the way, unlike everything else, it actually comes with Drizzle. So when you go to compile Drizzle, you actually get an online hot backup with it. It's not like you got to go out and go find it. It actually comes with the database. We're testing it with each version. We know that it continues to work. So you're not having to deal with the whole, this version versus this version or anything like that. It's actually already there. Something also that's pretty nice about it, just for another piece, because we store our replication inside of our NLDB tables, so they're actually stored in NLDB, you're actually getting, when you do a backup, you're getting your replication too at the same time, which means that you're getting a single snap copy, you're getting a single copy of what's happening here. There is none of this, shuffle of, well, what's the bin log here, or what was occurring here, and all of the other pieces that can fall apart in these cases. You're getting exactly what was there when it's run. So, kind of sharp. So, pretty thankful for coming for that. Another big thing, we've been really big on testing from day one. DBQP is an entirely new test framework. This talks something about our methodology. So every time new code for Drizzle is to be pushed somewhere, it goes what? That code goes into a build system that first tests it against a whole bunch of different platforms, tests it a bunch of different benchmarks, tests it for performance regression. We never did for MySQL. And then only at that point did it ever go to trunk. And we test every single push. No push goes in that allows regression, performance, bug-wise, anything. So it's not like you push a trunk and then later on, like 5 months later, somebody runs a benchmark on the thing and finds out, oh, it looks like you made a mistake 3 or 4 months ago, or whatever. Everything is tested from day one going in there. It's done DBT2, it's done SQL Bench, it's done SysBench, there's a couple of others. We do a lot of testing to make sure against machines with different types of cores. So we do testing against 4 cores, 8 cores, 16 cores, and 48 core boxes as well. We test these. So we look for regression across all of these things. And we can show from point 0, day 0, when the fork began, all the way to today where we're at. We have a very nice growth curve as far as performance goes. So we know where we started out years ago, and we know where we are today, which is kind of handy. The whole system is supported by SkySQL. It's got a bunch of its tools on it. You can use the test. You can test MySQL, whatever else you want to do. We have a new dynamic SQL executor. UTF part is being extended. GSOC summer basically Google Summer of Code students have been working on this. What it allows us to do is you can take any kind of string and it can then be executed in the database dynamically. Now we had this ability to do this in 7.0, but it doesn't quite work with UTF-8. In 7.1, everything will work with UTF-8. Think about it at some point. What does that mean? We actually now have an internal new API that can execute SQL in the database with dynamic SQL. We can actually start popping into our procedural languages if someone wants to, and we can do them as plugins. So if you don't want it, you just don't put the plugin in. If you want the plugin, you put it in. You know what? If you don't want whatever language is there, you can put together a plugin for whatever language you want. It all works. The way it's imagined today, for instance, the Java application, your Java application would be like any other Java application, and it would just connect to a JDBC. It would just have a normal JDBC connection. So to connect JDBC, it just happened to be internally in the database. It also means that if at some point you need to move that out of the database for performance reasons, you don't have to rewrite the code. The code will all be executed against the JDBC. So the idea is have affinity here when we need to, but at the same time, if we need to grow out, let's push things out and let things live on the outskirts. So this is a question that I didn't get asked a little bit. What's the whole thing working? It's been like 2.5 years or so to actually implement the whole thing. We got a bunch of questions. Could we have built it from Postgres? SQL. Sure, Postgres is a good database. We could have built it from it. We use C++. Postgres is not. It's C. We find it a whole lot simpler to work with. We have a whole lot of younger students that really never learned C and really are much more comfortable with C++. So anyway, we ended up going C++. We had debates whether it should stay with C or go one way or another. MySQL is C++. It's neither C++ nor is it actual C. It's a kind of a hybrid of the two. We decided just to say full bore, go C++ and make it go. What is a rat hole? We found that when we fixed things, there were a lot of bugs that we never expected to even run across. Before we went to release, I found this giant swath of bugs in the way that time was done inside the database. Just all kinds of things resulting in this time stuff we just never tested before. We did not have enough testing. It took me like 2 months to fix every time-related bug I could get my hands on. And there are still time-related bugs out there that I know exist that I couldn't point out and say, well, we are done with this. We are not going to go any further. We have fixed more than was there before. And there are just cases where these things will pop up. Are there bugs in Drizzle? I get this question like, do you have any bugs in Drizzle? The answer is yes, we have bugs in Drizzle. You can go to bugs.launchpad.net, Drizzle, and you can find all of our bugs. By the way, that's something different. We're the only open source database today that has a fully open bug tracking system. Or does bug tracking at all. So if you want to know what bugs are actually in Drizzle, you can go and search. Anything that's been entered is there. We're the only people who actually have the whole thing actually open nowadays. We have questions like, could we have rewritten it in Erlang? Whatever. Great. What does cloud mean? Well, whatever. You get these things, and Drizzle's been known as a lightweight, cloud database. Cloud. I don't prefer the word infrastructure. We really looked at it and tried to figure out how to make it a piece of infrastructure because, it's like databases used to be these giant islands unto themselves. People would say drop all the business logic in, they put everything in. You had cartridges that tried to have web servers built into it, so the whole thing would be from end to end this giant thing. Well, that's not the way people develop, and that's not the way people use tools. People use tools by taking different pieces, linking them together. Database, Drizzle itself, cloud database, whatever, infrastructure database is my favorite term. We've really tried to build it so that it's infrastructure aware. You can plug things like LDAP and PAM, plug other pieces into it, and then it can actually reside and live nicely and peacefully amongst everything else you're deploying. I mean, if you heard the talk this morning during the keynote, you heard like, okay, so that system, that system, that system, that system, that system. That's the reality of the environment. So you can't really force everybody into this one thing. Because you know what? Relational database, great for some things, poor for other things. Another great thing about the whole thing, we've had 120 plus developers since day one. We average about 26, 36 on average each month. Summer months have been a little less, we've been about 14, 16. We've had a bunch of companies who actually help to do development and a number who do support. My company, Differential, does basically engineering work and deployment work related to Drizzle. So does Percona. So should SkySQL, but their name isn't there. Aker has been a great company that's helped support us for a very long time. Primebase sends us developers. They actually wrote the triggering system and wrote the HTTP blob stuff. So, oh, that's Sun. He's a little Java guy. Rip, Sun. Sun put a lot of energy into it, so I always feel like we should put something up for them, but it seems more like appropriate logo. No, Gosling put out a blog, why not? So, anyway.
And production of those guys, who all do this in production?
All of us are actually, let's see, everybody here has been given, most of us are either service companies or people I can tell who just support stuff to get more code out there. Can't really talk about what the Rackspace is working on internally, but they definitely have Drizzle deployments going on there. So that's some of the stuff. If you're interested in more information, you can find more information out at http://drizzle.org. Freenode, pound Drizzle. We do a lot with IRC. Me, you can find on blog.pro.net, and I'm feed Brian Aker. At the same time, my company is called Differential. There's a Drizzle Twitter feed. There's all kinds of ways to find out information. So on that note, I thank you very much, and I can take some. Oh, there is a. If you're interested also in talking more to some of the developers who work on this, there is a Birds with Feather tomorrow night that you can go to on Drizzle. So that actually is happening tomorrow. On that note, let's see. Let me take some questions here. Go.
Yeah, so my question is primarily about the MySQL compatibility, etc. So can you talk a little bit about that? Like, what have you seen people doing? Can it be a drop-in repair solution now, or what does it look like?
So here's the question. Things are always good things. We had one large company who scanned, they had like 10,000 running applications. They did a big scan, jumped the SQL. They found that it was like 95% compatible with their application. So 95% of shit, like their applications all work just fine. No big deal. They had some more of that. You got to keep these MySQL. They were related to MySQL deployments where generally somebody does some work like in beforehand and wrote some string procedures. That's the usual case. But the typical bread and butter MySQL stuff, it all works fine. We added some more compatibility layers in 7.0 to make things a little more compatible. And in 7.1, I made some other stuff compatible just to kind of, basically, when someone showed up on the mailing list, I can see like, that's a low-hanging fruit. I usually grab it and make something that's compatible just to make stuff. But in general, you can't really tell from most applications. You can take the MySQL applications with the same clients, point them to Drizzle. PHP's MyAdmin, the guy who was working on it this summer, I think I fixed all of the bugs except for one he needed fixed to make everything work for him.
There's Drizzle dump that transfers data and schema across from MySQL to Drizzle, so it'll do the conversion of data and bad data.
Yeah, we have an application that can fully take data out of MySQL, transfer it over to Drizzle, and so. I think I'm gonna take questions up here and let everybody out the door. Thank you very much for coming in.